this is where we've been. Midpoints can be joined, two coordinates can be joined to make a line which has a gradient, which has a midpoint. Once we've got that, we can create an equation for the 2 points that are joined by the line. And when we've got the midpoint, we can find an equation that sits right through the middle of that line and cuts it in half, hence perpendicular bisector. And that's what the last work was about, and that's me showing you all the steps, and some of you followed it, others of you just cheated and took it off YouTube, and that was the task. And that's me showing you that I did the work as well. So in a moment we have to switch off our video so we can move on to the next bit. All this was all about today's lesson, but especially tomorrow's lesson. We have to deal with equations of a tangent that touches a circle. So I'm actually going on to page, and you should know this from your task now anyway, I'm actually going on to page 373. This is the last part of chapter 18, after which time there's just one chapter left for the year 10 stuff to finish, which means we'll easily finish that, but I want to go beyond that, well into year 11, since our time is squeezed. Can I ask you just to switch off your videos, you guys, or rather your cameras, so that when I do upload this to YouTube it won't be so glitchy. All right, just bear with me there. Ruben, okay, still with us, fine. Ruben wants his video on, I'm good with that, if that's what he wants to do. So let's just take a look, and we're about to lose Ruben. Excellent. So let's just go big, so we see what's going on. Now, a circle is a circle is a circle is a circle with an infinite number of sides, but a circle could be plotted on a coordinate grid, and as such a circle has an equation. It's not random, it's definitely that shape, and if it's got that predictable shape it will have a predictable equation. And here it is. It's fascinating. So if you're taking notes, or if you're really quick at taking notes, you should do so, or wait for the YouTube video to go up after this lesson, or you've got page 372 to help you take notes, and then that would enable you to do question 1, 2, 3, 4, 5, or whatever it is I set. I don't think I did question 1, but anyway. Here's the equation of a circle. The x coordinate squared plus the y coordinate squared will equal to the radius of the circle squared, provided the circle is plotted at the origin 0, 0, which is probably what that's doing there. Been there for years. And then just dump that. Oh, go away. Just dump it. Delete. Cut. Go away. Good. Right. Good night, Tom. Been there for a couple of years. Anyway. So x squared plus y squared equals r squared, which looks a little bit like Pythagoras, doesn't it? The two small sides squared make the radius squared. Well, what's that got to do with a circle, if we're talking about triangles all of a sudden? Well, behold, if you draw a rough circle with a pair of compasses, don't get too rough, and you have a point on the circumference, which means it must be as long as the radius, let's face it. Because if you're on the circumference, then from the centre to the circumference, you're a radius, that's what you are. And if this coordinate is called xy, because all coordinates have got an x and a y, then it's like going x along, however big that is, and y units up to reach that point, xy. If you've got an along and an up, you can work out the radius using Pythagoras. And here it is, a right angled triangle. X squared plus y squared makes radius squared. That's why it links to Pythagoras, because once you create a triangle within the circle, if you know the coordinate that you're drawing the radius to, you just do straightforward grade 4 Pythagoras and you've got the equation of a circle. So for question 1, for example, there's no fancy working out here. Write down the equation of a circle with centre at the origin, in other words 0, 0, and I think I did 1a here. Yes, I did. So here it is, I did question 1 by demo, page 373. So here it is, they want me to write down the equation of a circle from the origin that has a radius of 5. Okay, well here's the generic equation, not y equals mx plus c, no, that's just straight lines. It's x squared plus y squared is radius squared. But the radius is 5, yeah? That's what they said. Oh, so if I square it, I'll end up with 25. So here's the equation. Fantastic. X squared plus y squared is 25. Tick. That's the phone. I can't even get it. Is that all right? X squared plus y squared is 25. I want to shut the door because it's going to annoy me. Too late. I'm still annoyed. If you were to plot that with radius of 5, you'd stab your compass needle right there. You open up the compass so it becomes a radius of 5. You do a proper sized grid, and you just go swish. You just draw around and make a beautiful circle at 0, 0. So if it's got a radius of 5, the point right there must be 5, 0. The point right there on the y-axis must be 0, 5. The point right here on the x-axis in the negative direction must be minus 5, 0. And the coordinate on the y-axis in the negative direction will be 0, minus 5. You've got a load of 5s. Why? Well, because the radius is 5. And if I was to draw in another little line, say, just some random line, that will still be 5 centimeters long, and I can prove it, provided they give me what that coordinate is. But I'm not going to do that right now. All right, just be happy. There's a whole load of 5s or minus 5s. Don't know why I tick that. So I'm just saying this is how it would look. You plot this by opening up your compass, stabbing it right in the origin, 0, 0, draw around. That's it. Now question 2. For each of these circles, they've given us the equation, write down the centre. Well, this is GCSE. The centre is always going to be 0, 0. Now, for the other course I'm going to do is with some other kids, this circle moves all around the grid. But please forget that unless you want to do A-level. So at the moment, the centre will be 0, 0 for all circles. And I've got this question here. It says x squared plus y squared is 100. Okay, so that means the radius squared is 100, which means the radius must be the square root of 100, which means the radius of that circle with that equation is 10 units long, or is it centimetres? Doesn't say, so it'll be 10 whatever long. Is that all right? So this circle will have a radius of 10, and it will be centred on 0, 0. That's question 2 done. So question 1's easy, question 2 is easy, question 3 is easy. I probably haven't even demoed question 3. It's that easy. No, I didn't. Let's read it together, shall we? It says sketch. Sketch means not drawn to scale. You don't need to draw it to scale. It says sketch the graphs of each of these equations and label any intersections with the axes. In other words, just like I've done here. Let's pick the first one, 3a. The equation is x squared. I could write this, I suppose, if I don't get too glitchy. Let's have a little look, have an extra little look bit here. And this is question 3a. It says x squared, y squared, all comes to 49. And I've got to draw a lovely sketch of how that will look. Okay, let's just see if I can do it with this then. Lines, lines, boom. Okay, I've got to use the mouse button to make me do it otherwise. Yeah. So I'm going to draw a lovely little circle like that. And I actually think I've got a circle facility as well. There we go. Ellipse. Give me a circle. I've got to use an okay, fine. So here's my circle. Yeah, I can make it look like a circle any day. Yeah, beautiful. Let's make it look good. Lovely. Well, that's my rough sketch of a circle. Now, the English says, let's go back to red. Sketch the graph of each of the equations. Well, I'm just doing 3a for now. And label any intersections with the axes. Okay, great. Well, that's my framework. Any idea what the radius is, anyone? Now's the time to unmute yourself and talk.
7.
Yeah, it's 7. So the radius squared is 49. So the radius is going to be 7. That's it. So what's that coordinate right there?
7.
Yeah. And what's the equation? Oh, sorry. And what's the coordinate right there? And of course. And what's the coordinate right there? Thank you everyone for contributing. And that one's going to be nothing across, 7 down. There you, and that's it. And that's apparently quite a high grade, but anyway, this won't appear on a foundation paper. It's at least grade 6, but it does get more serious tomorrow, mind you. So we can do question 1, question 2, question 3, question 4. Let's just do one just for funsies, since we're in talking mood. I'm sure I'll press that anyway. Back to black, that's the bestest. I think I'll draw question 4A. I won't draw it perfectly because it's going to take too much time. So here's my circle, which is almost perfect. Here are my axes. Oh my goodness, that's terrible. Imagine that's perfect. There we go. There are my axes, and I've got a 3 there. I've got a something over here, nothing. I've got a -3 there. What should go here anyway? Just there. Yeah, the radius has got to be 3. And what's got to go here, really, honestly? Yeah, thanks, Hamza. That's nice. That's it. I've got to find the equation of that circle. Somebody start me off.
X squared plus y squared.
Yeah,
equals 9.
Equals 9.
Let's show our working. It's 3 squared. There's the radius squared. Let's get a mark for that. Come on, it's high level. And then we're going to say, hey, that's 9. Boom. And then we sign off, feel all proud of ourselves. So we can do question 1, 2, 3, and 4. I did say go up to question 5, so I may as well do one with you. I did some difficult ones. They're horrible, only because the numbers are horrible, but not because the question itself is horrible. It's just not. So I think I'll do one with you. So here's question 5 for funsies. Oops, should be in black, but anyway. So question 5, pick one. A, B, C, D, E. Oh, I don't know. How about I do B, just for funsies? Here's B. So I'm going to write down B. I've got the equation x squared and y squared is 25. Now let's read the English. The equation of the circle, that one right there on the screen, has got all these points sitting on it somewhere. Find the coordinates of the points where, and I'm going to do B then, where y is 4. So I'm going to plug in a 4 right there. Okay, so I've got x squared plus 4 squared is 25. Yep. So I've got x squared plus 16 is 25. I've got x squared is, what's 25 take away 16? 9? 9. So x is going to be the root of 9, which is 3. Find the coordinates of the points where y equals 4. Oh, so I've got the point 3, 4. Is that okay? That's my answer. Are you good with that, everyone?
Yeah.
Hamza's good. All right, so I'm told the y equals 4, so work out the x. For some of the others, you're told what the x is, so work out the y. It's not difficult, but some of them are difficult because, I'll just show you anyway briefly, it involves fractions, and nobody can do fractions, not really, and surds, but be saying about surds really, you can't simplify the square root of 2 to 1, so I just left it as it is. And another one involving fractions and surds, because I don't know what the square root of 99 is. He hasn't got one. But again, that's it. So these are starter questions. Just to reiterate, let's go to the beginning. Circles have equations. X squared plus y squared is the radius squared. The centre is always going to be 0, 0, the origin. And the radius would feature at the points where they cross the axes in 4 places. Of course, every single dot on that circle, and there's an infinite number of them, will have the same radius. Question 2, find the radius of the equation given. Question 3, what's this all about? I can't remember what question 3 is about. Yeah, find the points of intersection with the axes. So there's your y-axis, there's your x-axis. So you're given that. Radius is 7, so hence 7, nothing, nothing, 7, blah, blah, blah. That's question 3 done. Question 4, spot the equation. Again, that's a fantastic drawing, all slanted. It's the position of the graphics tablet. I can't get it better than that. So there we go. That's the equation of that line there. And question 5 is, there's an easy one. Find the missing point that sits on that equation. We don't need to do any more. for the simple reason that question 6, 7, 8 is all about tomorrow and needs some quality, slow time. The whole point we did the last lesson on perpendicular lines was really to look after questions 6, 7 and 8. All right? Now, there is a question 9 which I've not even mentioned in your show my homework task list, but I may have to demo one because some of you want to get grade 8, some of you might want to go for grade 9, so you must have exposure to it. So I may do some of those or one of those. It's essentially, if you're looking ahead, Samuel and anyone else, it's essentially a simultaneous equation. That's all it is. And I know you lot can do simultaneous equations where one is linear and one is quadratic. But in question 9, if you're going to take your eye down there, one is linear and the other is not quadratic. The other one is a circle. But hey, it's still got x's and y's in it, which means you can combine the two equations to make one equation, which then you can solve in the normal way. But that's going to be grade 9. And some of you might want to try that. If you do, great. If you don't, you don't. In the meantime,